This is the Iron Fireman. I am Iron Fireman. I don't know. Well, it's part of the Iron Fireman anyway. It has two dials labeled day and night, and it seems to be for setting the desired temperature because of the numbers. I mean, it's in the imperial units, but there's no electronics in this. It's just heat-sensitive metal and some mercury and some wires. I mean, how does it even know what constitutes day and night? This is a video about technology. Retro technology, isn't that the end thing to do? But this is a 95-year-old thermostat, and maybe a little bit of philosophy for the future. So this is quite literally the Iron Fireman. I am Iron Fireman. The Iron Fireman would load coal into the boiler automatically according to the thermostat. You'd load coal in here in the hopper, and yeah, it would just slowly fill it. So you might only have to refill this once every few days, or daily, depending on how it was. You wouldn't have to wake up in the middle of the night and go stoke that thing. So this is quite literally the rest of the Iron Fireman. This is the computer, but it's not a computer, it's just mechanical. It's extremely well made, but these little indicators indicate when is day and when is night. So you can program it by setting when these little mechanical indicators are. And you can also configure what the strategy is for how the Iron Fireman will load coal and wait a little bit for the coal to sort of catch on fire. There's also provisions for firing an electronic ignition. There's terminals here for wiring into the day and night thermostat, so that these are basically inputs for this, so that it can determine sort of what's going on with the rest of the sensors throughout the system. And this interface here is the interface to the thermostats that actually runs to the new system. So because of the dials, whether you want it to be night at 5 p.m. or 9 p.m. or midnight, you can set it that way on the dials, and it's not really a problem. It's a pretty clean and elegant solution. Daylight savings, you just come downstairs and move the dial. Once you set the time to whatever time it actually is, it keeps sync with time because it's counting the number of cycles on the alternating current electricity. Here in the US, that's 60 hertz. So this is basically a clock that's counting 60 cycles per second on the electricity, and it would keep time that way, and it was accurate enough. In fact, today there are some places around Niagara Falls that, because when the time changes, they'll actually, over the course of a month, sort of change the electrical cycle so they don't have to go around setting a bunch of clocks. It's weird, but yeah, that's a thing. It's the Google Nest thermostat of 1925. I see stories about people's cat feeder that stops working because some computer in Weehawken, New Jersey is having a bad day, and suddenly I don't want to live on this planet anymore. Now, I'm not trying to lead anybody down the Luddite movement here and convince you to deploy coal-fired boilers for steam heat for your house, but I did want to say if you have a custom loop in your computer, or an all-in-one, you're already using water to manage heat. Water is great for heating your home and cooling your computer. So steam for heating your home is one of those technologies that once you understand it, it's so elegant in its simplicity, and it can work well. There is some craftsmanship in your heat system, and yeah, it's up to you, and yeah, it can be a little bit fiddly, but once it's set up, it can be very inexpensive to heat a large space, and it requires very little maintenance. Technology moves rapidly. From 1925 to 1955, someone retrofit the existing coal-fired system to this, what's in here today, which is fired with natural gas. Now this system is a little different. It does have two safeties. It has one electronic safety. Well, more than two safeties, but two electronic safeties, or electrical safeties, I should say. And all the other safeties are mechanical. So there's one Honeywell sensor here. There's a pressure gauge here. This is just sort of an FYI. And then there's some pressure relief valves scattered around the system. It's a steam system, so generally it works best at about 10 PSI, or at least the systems that I'm familiar with seem to work best at about 10 PSI, 5 to 10, something like that. And so this could use some more safeties. Normally, you would take this pipe out and put some more electronic safeties on it. Some more Honeywell sensors basically that are electrical, but when the pressure's too high or something else, it just cuts it out. There's not really a lot of electronics there. It's a very sort of dumb safety. There's also a low water inlet, so if the water gets low, it'll automatically let more water in from the main supply line. And there is one low water cutoff, but generally these sensors are supposed to be changed about every 10 years, so I'll be getting some licensed help to do that. It's not super efficient. I mean, 78%, modern systems are a little better. But by contrast, our heat pump system over here, there's actually two, but this particular one is only about 50% efficient when it's near freezing outside, so at least for heat. Now, of course, old Bessie, she can't do air conditioning, so what are you gonna do? Now contrast that with a modern system like this one that was installed in 2006, and there's not really a lot that's changed. There's a few extra safeties, a little bit more electrical controls, but there's not really a lot here in terms of microprocessor or Internet of Things or anything like that. We still have mechanical blow-off valves. We have a float switch for automatically cutting the water off or automatically cutting the boiler off if the water's low, or automatically letting water in if the water gets low, but if for some reason water's not coming in, well then it'll shut the whole thing down. We have high and low pressure cutoffs, electrical as well as mechanical, and then of course everything else is for cleaning and draining and all the regular boiler maintenance that you should do. But there's an electrical ignition for the gas, but really this system is not a lot different, even though this system was installed in 2006. Now, if either one of these systems fail catastrophically, multiple different safeties have to fail. And there's also the yearly inspection, so, just to make sure. In addition to the safeties that you see here, there's a whole other set of safeties around back that are pretty much redundant versions of these. It's kind of like Starfleet. It's like, oh, we need 5 redundant copies of life support. Okay, sounds good. This is not exactly the Klingon Empire here. But it is really beautiful how elegant and relatively uncomplicated and easy to maintain these systems are once you learn a little bit about them, once you do some elbow grease. Now, but the worst that can happen with a system like this is if it does fail, other than the catastrophic failures, which are extraordinarily unlikely, especially in a low pressure system like this, is it's going to flood the room that whatever fails in. But in my experience, these systems do give you plenty of warning that, hey, maybe you should replace the valves or the pipe or the valves that let the cold air blow off of the radiators. You learn to listen for certain things, and maintenance becomes pretty easy. The same thing that attracts me to Linux, which is basically set it and forget it. You can count on it and it works great. It's pretty much true of Steam technology. That's what all technology should aspire to. Like, Google Nest is fine, Internet of Things is fine, but it should work without the internet in the same way that well, this one requires electricity to work, but the even older one doesn't even require electricity. It generates its own electricity for at least the thermocouple to detect from the flow of natural gas, which is the dangerous thing. I think we can count on electricity, but in 1950, I guess we couldn't. For software engineers or anybody building complicated systems, I think there's a lesson to be learned here, and that is complicated is not always better. Like, this system has a lot of engineering that goes into it, but it manifests in the components of the system that are elegant. You see that in the Linux kernel. There's stuff in the Linux kernel that every computer scientist can learn from. It's beautiful, it's elegant. This might not look beautiful, but the principles behind it are. These systems, they're incredible. I love being on the bleeding edge with technology, running 64-core Threadrippers and my 28-core Xeons, but it's just incredible to have a piece of technology that's 100 years old and still useful. I mean, to replace the heat plant, this older heat plant from the 1950s with a modern Well-McLean, it's only about $1,500 US, well, except for labor. But all the fittings and valves and everything else is already in place. And most steam systems that have, steam return and steam pipe, like condensate return and steam pipes, they can be retrofitted for hot water. So this particular boiler, the older one, heats water and provides steam throughout the system, and it's surprisingly efficient overall. Now, it doesn't help much with air conditioning, like I said, but lately I've found that split systems, mini splits, can be just as efficient to handle that. Similar to how the steam pipes carry steam and heat, you have some copper pipes that carry refrigerant, and so your coils and everything else are sort of on the inside and the compressors on the outside, and it's pretty easy to set those up, one for each room, maybe a little bit of forced air for bathroom, hallways, common areas, things like that. But I wanted to show you a little bit about steam heat and the technology that goes with steam heat. I love that you can make something awesome that people will be using long after you've died, long after you've gone, because genuinely, it's that good. I kind of like open source technology for the same kind of thing. It's enduring. So yeah, the heat plant here is a little bit ship of Theseus, but this is a system that was installed originally 100 years ago. It's been updated about every 25 to 50 years, give or take. And this is ordinary technology. No, we're not talking particle accelerators here. For me, there's a little something philosophical. As a society, I worry that we're losing too many of our craftsmen and artisans that can build and service such systems. Everybody that I have look on this, unless they're already experienced with boilers, looks at it and says, ooh, no, let's just put in a forced air system because that's what I know how to do. And it's like, well, I mean, do we really have to? I mean, it can be fine. For me, I care about the environment in the abstract sense of caring about the environment, but also the environment I create for myself, because I find that it's rewarding to do some of the work, the restoration, the refurbishing, building it, augmenting it, shoving a Raspberry Pi into it. I just find it very rewarding and satisfying to find my own purpose in doing those kinds of things, both in, software and hardware, like helping keep a boiler system running. Are we already so poor that planned obsolescence is all that we can afford with consumer goods? I mean, it may not make sense with the general advances in computing, like the advances in technology that have made coal obsolete. I mean, advances in solar could make the natural gas steam plant here completely obsolete, the same way that our iron fireman coal autoloader is obsolete. But one place we're not so poor in things is in software. We have the intellectual capacity to create a technical environment for ourselves that is not disposable, one that endures. I think that's open source. I think that, open source is much more mature than it used to be, but it's still more nascent, I think. As I think about making this home a smart home and that sort of thing, I keep going back to things like the Iron Fireman. I mean, if I put a bunch of Raspberry Pis, PoE Raspberry Pis, monitoring things, reporting things, doing little chores, figuring out the sprinklers and sunset, will that really be useful in 100 years? I mean, I can hook up the carbon monoxide detector and the carbon dioxide detector, and I can have a monitoring system for the oxygen level within my house, which is great, and there's safeties, and there's actually like Z-wave carbon monoxide detectors, so you get the first and second layer of failures. But I'm pretty sure that open source has the potential to be as enduring as the Roman roads and the aqueducts, and take security seriously and develop standards. But I don't think it's here yet. I don't think that we've quite achieved the, Roman aqueducts level of software. We're getting there. I wonder if that kind of thing is going to be useful for the next 5 years, let alone the next 50 or 100. I don't know, but join me, or at least join me so we can wax poetic about it. Now, I'm sure that open source does have the potential to be as enduring as the Roman roads and aqueducts and that sort of thing. But first we've got to get there securely and responsibly, and then maybe we can think about setting some industry standards. So I'm Wendell, this is level 1. There's something that we must rediscover, or something we must not forget about technology that's 100 years old. I mean, indoor plumbing, running water, proper heating. We have to build sort of these enduring facilities for ourselves. And we do it in our homes. I don't know that we do it in our homes in the modern day in a sustainable way, McMansions. I know that we're not doing it in a sustainable way with software, except possibly open source. But it's not a problem I could solve in one video. I just thought this was interesting. And Wendell, this is level 1. I'm signing out. You can find me in the level 1 forums. Oh, and in case you're wondering, you can get a natural gas heating cartridge for a heat pump or a forced air system, heat pump like forced air system, that's controlled electronically. So depending on what is the most efficient thing, the microprocessor can decide to use the heat pump to heat or natural gas to heat, depending on whether you want heat or air conditioning or how much heat you want and the temperature outside.